everyone, welcome back to our geometry class. In this video, we are going to continue our conversation about the density. As I mentioned in the previous video, we are going to do some practice in this video. And in the previous video, we already mentioned the definition of density, and also we figure out the connection between density, mass, and also volume. So just want to remind you again, since a lot of situation we are actually considering is on the Earth, so the mass is actually same as the quantity of weight. They have a same result, and of course they are, these two are different concepts, but right now we do not, tell so much difference since we are actually talking about the very pretty common situation. So in this video, we are going to do some practice. Let's check the first example. Also, you may notice the calculator is on the side, so we're going to use a calculator to help us to do some practice in this video, okay? So, example says a hemispherical water tank has an inside diameter of 10 feet. If water has a density of 62.4 pounds per cubic foot, what is the weight of the water in the full tank to the nearest pound? So a lot of situation, when we start reading this one, sometimes you are confused about, some keywords like hemispherical or pounds per cubic foot, all those kind of things. So first thing, I would just want to remind you, this is a unit for the density. So you don't need to, pay too much attention for that. Just because volume, the formula for density is mass over volume, so that's why it turns out to this kind of unit. So now let's check the final question. The question asking us to find what is the weight of the water. So according to what we mentioned before, and if we're looking for the weight, we can just directly to use this formula. We are going to use density times volume. So question now is going to be, what is the volume of this object, right? So we know we are going to use the density. I'm going to label around here, 2 times the volume. So the question is, what is the volume? We need to find the volume first. In order to find the volume, the very first thing we also need to understand is the volume of the object. So what is the object we're talking about here? And the keyword here is hemispherical. We know, before we know how to find sphere, right? Hemispherical is basically half of the sphere. So we just need to find, what is the volume of the sphere? And we just find half of that. Now let's just, write down the formula to see what we need to use. First of all, since it's, hemispherical, so we are going to times half because it's a half of sphere. And then we know the volume for the sphere is 4 over 3 pi r to the 3rd power. So question is, do we know the radius of this object? Which is another key information showed up is diameter is 10 feet. What does that mean? That means our radius is 5 feet, right? Because radius is half of the diameter. Now let's continue our calculation here. So it's going to be half times pi times 5 to the 3rd power. This is what happened here. And then I'm going to hold on here because, I always like to write down everything I need to, do the calculation, and then I'm going to type everything in the calculator and try not to run the answer before the final one, because sometimes if you run a little early, that might lead to 1 or 2 digits mistake. So the final thing is I'm going to find the weight, and the weight we know is going to be the density times the volume. So the density is already 62.4 times half 4 over 3 pi to the 5 to the 3rd power. It seems very long, but I just repeat whatever the volume here. Now we are going to do the final calculation here. So we are going to type everything here. By the way, before we also come to the final calculation, always double check if the unit is consistent. I see the foot here. Also, this is a foot, and the final answer asks a pound. We have pound here. So they are consistent. I don't need to do any conversion. So now let's put this calculation together. It's going to be 62.4 times a half times 4/3 times pi, which is second pi, and times 5 to the third power. And it seems long, but if you double check everything here, it's actually, as long as you type everything correct, you should be able to get the right answer. So 62.4 times half times 4/3 times pi times 5 to the third power. Then enter. So the final answer is this long number here, but now let's check. I need to round the answer to the nearest pound, so it's going to be a whole number. So after decimal, which is 2, we are going to save it, now to round it up, so which is 16,336 pounds. That's our final answer for this one. Now let's move on to the next question. Next question says the density of the American white oak tree is 752 kilogram per cubic meter. Again, this is just a unit for the density. Let's just not focus too much about this. And also it says if the trunk of the American white oak tree has a diameter of 1.04 meters and the height of the trunk is 8 meters, what is the approximate number of the kilograms of the trunk? So the final question is actually they change the way to ask that. When you check the approximate number of the kilogram, they're still talking about the weight because this is a unit of the weight. So again, like what we mentioned before, the weight is always volume times density. We know the density here is already given, but the only thing we need to find out, the first thing, is the volume. So some students might ask, we need to know the volume of object, but I don't know which formula we need to choose. I don't even know what is the object here. So the word here is actually coming from this is trunk. And if you like a part of the tree, so if you do remember, the trunk is look like big bottle, like a big jar like this. So it's actually look like what? A cylinder. So in order to find the volume of the cylinder, which is formula is pi r squared times h. So all we need to look for is what is a radius, which I have a diameter here, meaning I'm going to take a half of this. This is a radius, right? And also this is the height is already given. The height of the trunk is 8. I'm going to multiply 8. Some students might say, oh, I don't know what's going on with my pen. It's not responding. Sorry. Okay, hopefully it's better this time. So it's going to times 8. And now we just need to put in a calculator. Some student might say, can I do this calculator later? But some student might say, oh, this is just too many numbers. I'm afraid I'm going to get it wrong. So let's, type this one now. Oh, so let me clear. So it's going to be second pi times whatever you wrote. Is always a good idea to type exactly the same thing you have. And then times 8. Okay, so this is pi r squared times height. Okay, this is it. My suggestion is always write down a little bit more numbers here. You can just, write down 6.7959. Keep more digits is always a good idea. And then the final weight is going to be the density times volume. So I'm going to, every single answer, I'm going to use 752, which is a density, times the V here. So what I'm going to do, I'm going to go up to use our answer times. So what I do is this answer times the density, which is 752. Okay, so the approximate number of the kilograms, so we're going to keep the whole number, which is 5,101. The reason is rounded up because the 5 is greater than or equal to 5, so I'm going to round it up to this 10. Then this is going to be our final answer. Okay, very similar. The only difference is we just need to figure out the shape of the object, and then we choose the possible formula for us to use. Final question. This one has a table, and we are going to figure out which of the states has the greatest population density and what is that density. So the question for us, as I mentioned, sometimes we describe the density of the object. We use volume. Sometimes we describe how many people in a certain area. So as you can see, we can figure out if we have more people, density is higher. If we don't, then density is lower. And the way to find it, we use the population, how many people, divide by the area, and then we just need to figure out the answer. So very quickly, we just need to do some calculation. We're actually going to use a calculator to help us to figure out the calculation, and we just need to find out the final answer. So let's check the first one. 01893 divided by 43204, and so the first one is 1.6515. The reason I write more decimal, just in case I have more situation, I have more numbers, they have a same whole part but different decimal. Divided by 46923, and this one is 63613. Okay, last two, 1050292 divided by 1034. And this one, wow, this one is way much bigger, right? Seems the number is not so big, but this is a quite big number. And lastly, 5576412 divided by 970093, which is 5.9367. Okay, so the answer is quite obvious. The greatest density is coming from Rhode Island, which is 1,015. So it's quite big density. It seems that more people in a smaller area. So we already know the answer. The city, which is this one, and the final density is this one. Okay, actually, let's check. Round the answer to the nearest tenth. So that's why this one is gonna be 1015.8. Just because to the nearest tenth, I'm going to round it up. And this is 5. Okay, so this is all the 3 questions to understand. I'm going to practice with you. We practice together about the density. Hopefully this is helpful for you to understand what density is and how do we find out the density, or using density to find out the different quantities based on the different situation. Thank you so much for watching this video. See you soon, everyone.